Fantastic. Niklas Kunkel, founder of the Chronicle Protocol. Thank you so much for joining us. Great to see you rocking the branded merch there as well. Bonus points. Okay, choose a mic, any mic. We've got lots of mics here. We've got a wonderful clicker with your name in it right here. You can drive the slides. So you are in control.
Lovely.
Fantastic. The stage is yours, my friend. Enjoy.
Okay, thank you very much. Hi, my name is Niklas Kunkel, and I'm the founder of Chronicle Protocol. If you're not familiar, Chronicle Protocol is an Oracle protocol. And so a little bit of context for those of you who are new, what is an Oracle? What problem do they solve? I think the easiest way to explain it is that blockchains are like black boxes. They don't have access to any information outside of the blockchain, right? A good analogy might be when you put your phone in airplane mode, right? All of a sudden, your applications can't, send and receive data anymore, right? And your phone becomes really useless, right? So crypto applications are the same way. And the only way that they can kind of get access to data is through oracles. Oracles are kind of the solution to this problem. So a little bit about our origin story. You may not have heard of Chronicle, but you may know us by our previous name. So we were part of a company called MakerDAO. I was actually part of the founding team of MakerDAO going back to 2016. MakerDAO is one of the largest DeFi protocols on Ethereum, and it creates the stablecoin DAI, right? And Chronicle is the oracle for Maker, right? So we secure all of the assets in MakerDAO, and since going back to basically June of 2017, right? So we were actually the creators of the first oracle on Ethereum. So before Chainlink was even a white paper, when we were developing DAI, right? We had to kind of develop everything from scratch, right? There was no DeFi, there was no DEXs, there was no Oracle. So we'd actually developed, right, the first Oracle on Ethereum. We developed the first DEX on Ethereum, and just so we could eventually develop DAI. So currently, MakerDAO has $6 billion in assets under management in TVL, right? And Chronicle oracles are securing all of those assets right now. So in order to kind of understand, what kind of sets Chronicle oracles apart and what makes them so compelling, I think we kind of have to start with taking a sobering look at the current landscape, right? So let's start with kind of the price of oracles. The cost of oracles is exorbitant. They use an enormous amount of gas, right? They cost an enormous amount of transaction costs. And this is just due to kind of the fundamental architecture of how oracles are engineered today. And this is a huge problem. In order to give you an idea for the sense of scale of this problem, at MakerDAO in 2021, we probably spent almost $6 million in gas, right? So it can really add up, and for a protocol like Maker, right, they can afford something like that. But what is everybody else supposed to do? Are you just supposed to rely on oracles, that aren't as secure or aren't as decentralized, right? And no, we shouldn't be cutting corners. We shouldn't be making these trade-offs, right? And typically, the way that you bring these costs lower are band-aid fixes at best, right? Maybe you update the oracle less frequently, right? But now the oracle is less accurate if you're not updating the data as often, right? Or maybe you use a smaller set of validators, right? But now the oracle is less secure and less decentralized because only a few parties now need to collude to kind of manipulate the oracle. So these are not really viable fixes for this oracle scalability problem. They're more like band-aid fixes. And so what we really need is a real engineering solution to this problem of scalability. Furthermore, oracles today are kind of like a black box, or they're kind of like fortune tellers. So when you look at an oracle today, this is kind of what you see, right? Oh, here is an asset pair, right? And here is a piece of information, right? Like a price. But you as a user of this oracle, you have no context for this data. You have no guarantees that this data is correct, and you don't know the origin of this data or the provenance of this data. Where did this data come from, right? So you're really just kind of blindly using this data, and that's a really big problem, right? Because we've have like these super transparent, blockchains. We've invested billions of dollars into building transparent blockchains, right? Into building decentralized protocols that are transparent. But then when it comes to infrastructure like oracles, we just kind of like are fine with the black boxes that oracles currently are today, right? And we need to solve that problem, right? All data should be verifiable and have kind of provenance and origin and context attached to it. So what did Chronicle do? Well, we created a new Oracle protocol called Scribe, which addresses all of these existing challenges of oracles. So if you take nothing else away today except for this slide, this is what I want you to remember. That Chronicle is a decentralized Oracle protocol that is both verifiable and scalable. And so we're going to get into each of these little categories for a second. So starting with decentralization, right? Chronicle is powered by a network of decentralized feeds. You can kind of think of them as validators. And we only select validators that are the top tier kind of crypto projects, right, who have built up and established a reputation, right? That they are high quality partners, that they operate with integrity, right? And so as a user of a Chronicle Oracle, right, you're not putting your trust, right, in Chronicle. You're putting your trust in this kind of consortium consensus, right, produced by these feeds. And so who these feeds are is incredibly important. And so, we feel very fortunate to have, partners like MakerDAO, like Infura, Gitcoin, DYDX, Gnosis, and all of these great partners. And so as you add more feeds, right, as you make this set bigger, right, it becomes more and more, the Oracle becomes more and more secure, right? Because you need to, in order to kind of compromise the Oracle, you need a super majority of this kind of feed validator set, right, to act maliciously, right? So the Oracle kind of becomes more and more secure and more decentralized as you add more high quality feeds. So here's a screenshot of our dashboard. You can check it out yourself at chroniclelabs.org/dashboard. And you can watch all of these feeds, right, update their data, right, in real time. So they're constantly, pushing these attestations, right, about, okay, at this second, I think ETH is priced at this. At this second, I think Rocket Pool ETH is priced this. At this second, I think, Matic is priced at this. So it's just a real-time kind of stream of data attestations coming in. So with that said, let's kind of delve into verifiability a bit, right? We talked about the importance of data, having kind of context attached to it, right? The provenance of data. And what I want to stress is that, transparency is not enough. What you also need is legibility. And that's where I think kind of verifiability kind of comes into play. Is verifiability is this combination of where transparency meets legibility. And so it's not enough to just be on a blockchain and say, oh, it's transparent because it's all on chain. It's not transparent if only a senior Solidity developer, right, can make sense of like a bunch of random hex data, right? It's only really transparent, it's only really verifiable when everyone can do it. And so that's what we've tried to achieve with Chronicle, is when you take a look at our dashboard, right, and you have this Oracle here, right, you don't just see the Oracle price, but you start getting context for, okay, well here we have this price because all of these validators, right, reported the following values. And this price was based off the model, provided by all of the attestations between all of these different validators. But we can go one step further and we can say, well, hey, Argent, why did you report that your price is, 155.490, right? We want more context, right? We want to know what is the origin of this data. And you can do that Because Argent says, well, I reported this because I went to Binance and I checked this pair, and I went to Kraken, and I went to Bitstamp, and I went to Gemini, and I went to Coinbase, right? So you really have this end-to-end traceability of like, this is where the data came from, this is what the validators reported, and this is why the Oracle is reporting this particular data as the canonical value on chain, right? And so this is something that no other Oracle does, right? Every other Oracle will just give you like, here's the price, or here's the final piece of data, right? Take it or leave it, right? And that's kind of the anti-pattern that we want to get away from. But you can even verify all of this data in your browser, right? So this attestation that Argent made, right, that the Argent validator made, right, along with all of this contextual data of, I got this from Binance, I got this from Coinbase, it's all been attested to cryptographically. So you can verify the cryptographic signature in your browser to convince yourself that this is a valid update by this feed. And if you were to change something about this attestation, right, if you were to change the timestamp by a second, then the message attestation, when you try to verify it, it won't verify anymore, right? So this would not be accepted by the Oracle as a legitimate update. And so the last thing I want to touch on is scalability. And this is what I think that makes Chronicle really unique and powerful compared to existing Oracle solutions, is that we have really solved this scalability problem. Like, we are never going to have this problem again of protocols spending, millions of dollars a year just on the transaction costs to update an Oracle. Like with Scribe, this is a solved problem. So we've come up with an algorithm which we call optimistic Schnorr. Schnorr cryptography is used heavily in Bitcoin for a number of years now. So it's quite battle tested and battle hardened in terms of its security. But it essentially gives us a really important property. And that property is that instead of having, X number of validators, giving data attestations and therefore generating X number of signatures, right? You have this one-to-one relationship of, validator to signature. With Schnorr cryptography, what we can do is we can have many validators, right, work together to generate one signature. And this is kind of the core kind of piece of what makes Chronicle so scalable compared to existing Oracle solutions. And so kind of our goals with this implementation, right, were one, the primary goal was to decouple this relationship of the number of validators kind of being linearly proportional to the transaction costs to update the Oracle. We wanted to, right, because this presents a moral hazard, right, because it means that if you can use less validators, right, to keep the costs lower, right, now the Oracle provider has a moral hazard where, of course they want to use less validators, right, because it means they can generate more profit. But this is terrible from an end user perspective because less validators means less security and less decentralization, right? So we really wanted to decouple this relationship, right? And this optimistic Schnorr algorithm that we came up with allows us to decouple that relationship. So unlike other protocols, other Oracle protocols, which have to limit the amount of validator, right, and have limited security and limited decentralization, Chronicle can support a near unlimited amount of validators for the same kind of fixed Oracle update cost. And that's like that's the secret sauce. That's what makes Chronicle so amazing. So couple obstacles that we ran into were that we wanted to have like a single implementation of kind of the Chronicle oracles that works across every single chain. And for those of you who know a little bit about blockchains, you kind of know that they're all different. They all have different properties, especially in how they structure the transaction costs. So on Ethereum, for example, compute, like execution cost, is relatively expensive, but data is relatively cheap. And then you have layer twos, right, where it's actually the opposite, right? You have compute that's relatively cheap, but data that's relatively expensive, right? And so these are kind of polar opposite kind of environments. So how do you come up with a solution that optimizes for scalability, right, on both of those kind of paradoxically, polar opposite kind of chains? And then the other obstacle we ran into is that, I think colloquially we've come to grips with this term of like, oh, these chains are EVM compatible, right? And I think what people mean by that is that, oh, if you have an application on Ethereum, right, and another chain is EVM compatible, right, then you should, in theory, just be able to copy paste your application on this other EVM compatible chain, and it should just automatically work without having to change anything. Yeah, this is a total lie. Every chain is completely different. EVM compatibility doesn't necessarily mean EVM equivalence. And so you end up having chains that are radically different, right? And start having to make changes across different chains. So, it was really difficult to come up with a kind of solution that would just kind of work out of the box everywhere, right? Without having to change anything. So I wanted to kind of give you, I've talked a lot about scalability, but I kind of wanted to give you just a raw numbers look of just how much more scalable we are, and just to show you like the dramatic difference between us and like existing Oracle solutions. So Chronicle with any number of validators, could be 1, could be 1,000, could be 100,000, it will always just cost 66,000 gas. And if you compare this to the likes of Chainlink and Pyth and Redstone, I mean, we see that this is a dramatic improvement, right? So in terms of the kind of cost of the Oracle, right? I mean, we've really managed to scale this at the limit, right? To give you an example of just how low 66,000 gas is, 21,000 gas is the default kind of Ethereum, transaction amount that you pay, right? It does, if you were to send an ETH to someone, right, it costs 21,000 gas, right? So, 66,000 is very, very much at the limit. So, for those of you who are more technical, I want to give like a very, very brief rundown of how the algorithm works. For the rest of you, like who aren't as technical, bear with me. But we're almost done. So we talked about these feeds before, right? And so these feeds, what they do, right, is all of these feeds as a group, right? They sign what's called a Schnorr signature, right? This one kind of signature that they all, collaborated to generate. And then what we do is one feed will kind of sign a vanilla signature on top of the Schnorr signature, kind of generating what we call a promise, right? And so this feed is promising that if you were to verify this Schnorr signature, it would represent a certain piece of data. Relays then kind of push this combination of the Schnorr signature and this promise kind of signature and the actual data and the timestamp to the Oracle contract. And what the Oracle contract will do is it won't actually verify the Schnorr signature. The only thing it will do is verify the promise. And so that is an extremely, extremely cheap operation, and that's kind of what makes this so scalable. And so what we then say is, well, this price is now optimistic. It's not set in stone, right? We didn't verify the signature produced by all of the consortium of validators, right? We just verified the promise of one of them. And so we have like a 10-minute kind of what we call an optimistic delay, right? And during this 10 minutes, right, this price is not set in stone yet, and it can kind of be challenged. So it's very similar to kind of the optimistic roll-up model of like, you commit things optimistically, and then you let someone else challenge them. And so during this challenge period, during this 10-minute period, right, anyone can call the challenge function. And what the challenge function does is it just verifies the Schnorr signature, right? So there's no data availability problem, right, of like, where do you get the data? No, it's like already in the contract. All you have to do is call verify. And what will happen if the challenge is successful is the feed who made the invalid promise gets banned, and the optimistic price is dropped, right? And the challenger gets a reward in ETH. So that's, I know it's a little bit complicated, but I know there's a couple developers in the audience who really nerd out on this stuff. So thanks for bearing with me. So that's it for me today. But if you are interested in using Chronicle oracles, please get in touch with us. You can reach us at our email, hello@chroniclelabs.org. Reach out to us on Twitter @chroniclelabs, or join our Discord at chat.chroniclelabs.org. Hope to hear from you. We're also hiring for a technical project manager. So if you're interested in oracles, if project management, right, is your blood, sweat, and tears, dream, please come join us. Would love to talk to you. Thank you.